Indeed. Let's take a little tour of the solar system. And since we only have a few minutes, we're only going to talk about some of the exciting things that have happened over this last year. And of course, the first one occurred in October. And this is when this particular object passed Earth at a point where we could actually observe it. At that time, it was called 2017 U1. And it turns out it was an asteroid. But it wasn't an asteroid made in our solar system. It came from outside our solar system. This is the first interstellar object like this that we've seen. Now, you may have read Arthur C. Clarke 40 years ago, Rendezvous with Rama. And there's it's a really exciting book. And indeed, it's an object that passes through our solar system. It's a very elongated object. And here's what we found out about this particular object observed by the Pan-STARRS telescopes in Hawaii. And of course, they got to name it. But they didn't name it Rama. They named it Oumuamua. Now, Oumuamua is a scout, a visitor from afar. And so it's very appropriate a Hawaiian term. And we've gotten now a number of other telescopes to observe it. It spins. And here are some of the characteristics that we find. It has a width of 1 and a length of 10, where it's 400 meters tip to tip. So that 10-to-1 ratio is really unusual. Let me give you an example. In our own solar system, our own asteroids, as they come together and start to accrete, they can be elongated. And when we look at those, we see the most elongated ones are 3-to-1, all right? And they are typically rubble piles, material that's put together as they spin. And so this thing, which has a spin period of about 7 hours, spins in this manner. And so this is leading a lot of our planetary scientists to believe it's not an accumulation of material like a rubble pile, but it's a shard. Something impacted perhaps a terrestrial planet, which blew it away and is passing through our solar system. So it'll be around for a little while. We're going to study it for many more months. And that'll give us an opportunity to find some more characteristics. It's reddened, which means it's been in space for quite a while, being hammered by cosmic rays. We call that space weathering. Now I want to talk about Cassini. Cassini's been in the Saturn system for quite a few years, and it ended in September 15th. And this gives you an overview. It's a beautiful little overview that talks about the flybys of Titan and Enceladus and many of the moons on a year-by-year basis over the lifetime of Cassini. And indeed, it orbits Saturn outside the rings. In fact, one of the reasons why we decided to ditch Cassini into Saturn is because of the moons Titan and Enceladus. These are really spectacular objects. And Mike talked about weird life, and of course what he was thinking about was humans. But this particular body, which has liquid on its surface, liquid lakes of methane, and plenty of hydrocarbons, may indeed have a life associated with a completely different model, and we call that weird life. Enceladus, we know, has an undercrust ocean that has leaking out of the cracks, flying into space. And because of the potential astrobiology nature of these two moons, we decided to ditch Cassini. And so one of the ways we've done this is here's the orbit trajectories of Cassini. And by interacting with Titan, we can get to fly between the planet tops and the rings. Where's my technician? Where should I be standing and not standing? And so indeed, some of the more spectacular things that we see when we fly over the planet, northern and southern hemisphere, and through this gap above the atmosphere but below the rings, is we get spectacular observations of these moons, these shepherding moons that indeed keep the rings in check. And here's an array of those, and they're absolutely spectacular. And in fact, if I zero in on one, this is Pan. Pan is in the inky gap. And as you can see, it almost looks like a piece of ravioli. And indeed, material in this ring actually crosses the gap. Ring material fall onto the planet. So over time, we anticipate that Saturn will lose all its rings. But in the meantime, as these particles are making their way across the gap, they are accreted in the belly band of Pan, and it takes on this neat little structure as it scoops up the ring material as it orbits Saturn in the ring area. This actually is a mosaic of many images that Cassini took just before it did its final plunge. It flew over the pole and down into the atmosphere just above the rings, with the Earth on the other side of the planet, so that we could observe it all the way down to the end. It's an absolutely spectacular image of Saturn. So in one of these ring crossings that we did, here is the high-resolution imager looking at the planet. Now, Saturn's got this beautiful haze, and it's really difficult to see the banded structured clouds like we see on Jupiter. But now that we've done this really close flyby, and we did 22 of these before we ditched the satellite, we're seeing all kinds of structure in these images, and it's really been a spectacular set of data. Now, when we went through the ring plane, we actually turned the spacecraft such that it was antenna to ram. That's what we call it, and that is in the direction of velocity, such that, and there it goes, it's antenna to ram, and as it crosses that ring plane, then indeed, if there are particles which are raining out of the rings and falling on the planet, that protects the spacecraft because it'll hit the antenna and vaporize. And indeed, we were surprised that we only really ended up hitting about 6 or 7 particles in that trajectory, and then we decided we had the flexibility to reorient the spacecraft and do a variety of other fabulous science. So, another one of the missions is Juno at Jupiter. And so these are the spectacular images of Jupiter rather, by Juno. And in fact, these cloud structures are approximately a third of the size of the Earth. And they're really pretty spectacular. So I'm going to take you on a trip on one of the more recent observations. These were done in July. And here's an altitude chart. The closest approach we actually get is about 1,500 kilometers. But it gives us an opportunity to actually do a three-dimensional view and look at the cloud structures, and then reassemble the data and actually fly through it in this manner. Now, we also have a microwave imager, and what this particular microwave does is it measures the heat from the planet. You know, Jupiter was like a cake. We pull it out of the oven, and it's still cooling off. Now we're flying into the planet, and you can see the temperature is roared down, and then we come back up, and we come right out of the out of the red spot on Jupiter. This is the red spot in our high-resolution imaging. This particular spot is about the size of the Earth. It actually extends downward more than 350 kilometers is what we're finding out. It is indeed a very hot set of material. It's rotating in a counterclockwise manner while all the other clouds are moving in a banded direction around it. So it's really a pretty spectacular set of data. The next one I want to talk about is really New Horizons and its flyby of Pluto. You know, it took us about a year after we flew by Pluto in 2015 to get the data down, and now we're really starting to take a look at it. And one of the things that we found, of course, is this heart region, and we wanted to know all about it. Many of us, and that included me, expected this to be very cratered, look much more like the moon than it does. The fact that it's not tells us this is an active body, and it's resurfacing itself. And indeed, this is a particular cold trap where the atmosphere, as it collapses, falls into it. And there's a nitrogen in the atmosphere, so this is nitrogen ice. It's got the consistency of toothpaste. And indeed, as we look into these edges of where these ice fields are, we can actually see examples of where they have moved around the ice mountains. And these are water ice mountains, by the way, and carved smoother regions on the body. Now, this particular section is called Sputnik Planitia. And we have IAU names now. These are approved names for all the major features on Pluto. And this is a depression. This is lower than the surrounding area. And this has caused us to think about how this could occur and its dynamics with its moon Charon. Now, both Charon's rotation, its orbital period around Pluto, and Pluto's rotation are the same. In other words, you can literally draw a line between Charon and through Pluto, and that stays the same. Now, Charon's pretty massive. It's about half the size of Pluto. Pluto's 2,000 or so kilometers in diameter, and it turns out they orbit the center of mass, which is outside of Pluto. So it's like a dumbbell type of rotation. Binary stars actually do this kind of rotation. Unlike the Earth, who's the massive part of the Earth-Moon system, and the barycenter is inside the Earth, the barycenter for this system is actually outside the Earth. This has caused us to think about how this structure has occurred. Knowing that this is an impact and it's lower than the rest of the area, it's a cold trap where nitrogen fills in this area. This is where the crust, the mass of the crust, is the lowest density. And so now we're envisioning, indeed, that in its past, an impact may have occurred. And through tidal forces, this impact allowed the crust to slide in a slushy area below it, perhaps it's a water layer, to the point where the massive part of the crust is really aligned with Charon, and the least dense part of the crust, where that left ventricle of the heart is in the opposite direction. So indeed, Pluto's a pretty spectacular object, and New Horizons still is moving, and it's moving to its next object. And that object is a Kuiper Belt object. It's MU69. And this summer, we did a variety of stellar occultations. This was probably one of the most spectacular set of stellar occultations we ever did. We lined up a series of telescopes, and we looked at a star, and MU69 moved in front of it. And it allowed us to get an idea to the size and how far it is. And right now, we believe that that particular object may be a binary. Now, this means that when we fly by MU69, we have a lot of exciting things to look at, maybe more than one object. And so these are building blocks of larger objects like Pluto. They're probably about 20 kilometers in size. You know, where Pluto is 2,000 kilometers, and so indeed there are those building blocks out in the Kuiper Belt. So those are just some of the exciting discoveries that are being made in planetary science this year.